wiring diagram provides crucial electrical specifications and connections for a spot hub. It usually contains information on the circuit size and breaker rating, the wire gauge and type, the voltage and amperage draw, and component connections. Conversely, the identification plate is attached to the spot hub motor and offers basic details about the motor. This includes the model number, amperage draw, and voltage rating. When an authority having jurisdiction, or ORJ, mandates a 20 amp circuit for a spot hub based on the wiring diagram, even if the identification plate shows a 7.2 amp motor, this requirement takes precedence for several reasons. Firstly, safety is paramount. The wiring diagram considers the total electrical load of the spot hub, which encompasses not just the motor but also the pump, heater, and other components. A 20 amp circuit provides essential protection against potential overloads and short circuits. Secondly, compliance with electrical codes is crucial. The AHJ is empowered to enforce local building and electrical codes. These codes may stipulate the minimum circuit size necessary for spot hubs to ensure safe operation and prevent hazards. Thirdly, manufacturers' recommendations play a significant role. While the identification plate offers specific information about the motor itself, the wiring diagram represents the manufacturer's broader recommendations for the correct and safe electrical installation of the entire spot hub system. In summary, the AHJ decision to require a 20 amp circuit for the spot hub, even if the motor plate indicates only 7.2 amps, is justified on the grounds of safety, adherence to electrical codes, and following the manufacturer's installation guidelines. Therefore, it is crucial to adhere to the wiring diagram specifications to guarantee a proper and safe electrical installation. Understanding the specifics of electrical diagrams is critical for safe and effective installations. Diagrams detail the intricate connections, ensuring each component receives the correct power and is protected against overloads. It's not just about meeting the minimum requirements of the motor, it's about the entire system's needs. For example, a heater might draw a significant amount of current intermittently, and the circuit must be able to handle these surges without tripping or causing a fire hazard. The wire gauge specified in the diagram is also critical. Using a wire that is too thin can lead to overheating, voltage drops, and even fires. The amperage rating of the circuit breaker is designed to protect the wiring from excessive current. If the wiring diagram calls for a 20 amp breaker, it's because the total expected load of the spot hub could exceed 15 amps under certain conditions. Local codes also play a crucial role. They often have specific requirements for spa and hot tub installations, including grounding, bonding, and the use of ground fault circuit interrupters, or GFCIs. These codes are in place to protect users from electrical shock hazards, especially in wet environments. The AHJ decision is based on a holistic view of safety and code compliance, ensuring that the installation is not only functional but also safe for the occupants. Ignoring the wiring diagram in favor of only the motor plate information would be a short-sighted approach. It could create a dangerous situation, potentially leading to equipment failure, electrical shock, or fire. The manufacturer designs the entire system to work within certain parameters, and the wiring diagram reflects these design considerations. It is important to consult with a qualified electrician to ensure that all electrical work is performed correctly and in compliance with local codes. They can assess the specific requirements of the installation and make sure that the circuit is properly sized and protected. They can also verify that all grounding and bonding requirements are met, minimizing the risk of electrical shock. Remember that electrical work can be dangerous, and it should only be performed by trained professionals. Attempting to do it yourself without the proper knowledge and experience could put yourself and others at risk. Always prioritize safety and follow the guidance of qualified experts. In addition to the total electrical load and safety considerations, it's essential to understand the concept of continuous load. The National Electrical Code, or NEC, defines a continuous load as one where the maximum current is expected to continue for 3 hours or more. For continuous loads, the circuit breaker and wiring must be sized to handle 125% of the continuous load. This means that if the spot hub's heater is expected to run for extended periods, the circuit must be oversized to accommodate the additional current draw. The wiring diagram takes this into account, ensuring that the circuit can handle the continuous load without overheating or tripping. Moreover, the type of wiring specified in the diagram is also crucial. Some types of wiring are better suited for wet environments than others. The NEC has specific requirements for wiring in damp or wet locations, and the wiring diagram will typically specify the appropriate type of wiring to use. This helps to prevent corrosion and ensures that the wiring will last for many years. In conclusion, the AHJ requirement for a 20 amp circuit based on the wiring diagram is not arbitrary. It is based on a thorough assessment of the spot hub's electrical needs, safety considerations, code compliance, and manufacturer's recommendations. Following the wiring diagram is essential for ensuring a safe and reliable electrical installation. Ignoring it could have serious consequences, including equipment damage, electrical shock, and fire. Always consult with a qualified electrician and adhere to local codes when installing a spot hub or any other electrical equipment. Remember that safety is always the top priority. In addition to the previous points, let's delve deeper into the specific components that contribute to the overall electrical load of a spot hub and why a 20 amp circuit might be necessary even if the motor's nameplate rating is significantly lower. Firstly, a heater is typically the largest power consumer in a spot hub. Heaters are responsible for maintaining the water temperature at a comfortable level, and they often draw a substantial amount of current, especially during initial heating or when compensating for heat loss in colder climates. The heater's wattage rating directly influences the amperage draw, and this is a critical factor in determining the appropriate circuit size. Secondly, the pump is responsible for circulating the water through the filtration system and jets. While the motor's nameplate rating might indicate a lower amperage draw, the pump can experience increased load under certain conditions, such as when the filter is clogged or when multiple jets are activated simultaneously. This increased load can push the amperage draw closer to the circuit's capacity, making a 20 amp circuit more appropriate. Thirdly, other auxiliary components such as lights, ozonators, and control panels also contribute to the overall electrical load. While these components may not draw as much current individually, their combined load can be significant, especially when they are all operating simultaneously. The wiring diagram accounts for the total load of all these components, ensuring that the circuit is adequately sized to handle the combined demand. Furthermore, the wiring diagram may also specify the use of a dedicated circuit for the spot hub. A dedicated circuit is one that is used exclusively for the spot hub and is not shared with any other appliances or devices. This helps to prevent overloading the circuit and ensures that the spot hub has a consistent and reliable power supply. The NEC typically requires dedicated circuits for spot hubs and hot tubs to enhance safety and prevent nuisance tripping. In addition to the electrical load, the wiring diagram may also provide information on the grounding and bonding requirements for the spot hub. Grounding and bonding are essential for preventing electrical shock hazards, and the wiring diagram will typically specify the appropriate grounding and bonding methods to use. This may include connecting the spot hub to a grounding electrode system and bonding all metal components of the spot hub together. The AHJ will typically inspect the grounding and bonding connections to ensure that they are properly installed and meet the requirements of the NEC. Finally, it is important to note that the wiring diagram may be updated or revised by the manufacturer from time to time. It is always a good idea to check the manufacturer's website or contact their customer support to ensure that you have the most up-to-date wiring diagram for your spot hub. Using an outdated wiring diagram could lead to incorrect electrical connections or an undersized circuit, which could create a safety hazard. In summary, the AHJ insistence on a 20 amp circuit based on the wiring diagram is a comprehensive safety measure that takes into account all aspects of the spot hub's electrical requirements. It is not simply based on the motor's nameplate rating, but rather on the total load of all components, the potential for continuous loads, the grounding and bonding requirements, and the latest manufacturer's recommendations. Following the wiring diagram is essential for ensuring a safe, reliable, and code-compliant electrical installation. Let's delve into the specifics of wire gauge and its importance in spot hub electrical installations. The wiring diagram will not only specify the amperage rating of the circuit, but also the appropriate wire gauge to use. Wire gauge refers to the thickness of the wire, and it is typically expressed using the American wire gauge, or AWG system. The lower the AWG number, the thicker the wire. For example, 12 AWG wire is thicker than 14 AWG wire. The appropriate wire gauge is determined by the amperage rating of the circuit and the length of the wire run. Thicker wires can carry more current without overheating, and they also have lower voltage drop over long distances. The NEC provides tables that specify the allowable ampacity of different wire gauges based on the type of insulation and the ambient temperature. The wiring diagram will typically specify the wire gauge that meets or exceeds the NEC requirements for the spot hub circuit. Using a wire gauge that is too small can lead to several problems. Firstly, the wire can overheat, which can damage the insulation and create a fire hazard. Secondly, the voltage drop can be excessive, which can cause the spot hub's components to malfunction or operate efficiently. Thirdly, the circuit breaker may trip frequently due to the increased current draw. The AHJ will typically inspect the wire gauge to ensure that it meets the requirements of the wiring diagram and the NEC. They may also check the wire connections to ensure that they are properly made and that there are no loose connections. Loose connections can also cause overheating and voltage drop. In addition to the wire gauge, the wiring diagram may also specify the type of wire to use. There are several different types of wire available, each with its own unique properties and applications. Some common types of wire include THHN, THWN, and OFF. THHN wire is typically used for dry locations, while THWN wire is suitable for wet locations. UF wire is designed for underground installations and is resistant to moisture and corrosion. The wiring diagram will specify the type of wire that is appropriate for the spot hub's installation environment. For example, if the spot hub is located outdoors, the wiring diagram may specify the use of UF wire for the underground portion of the circuit. Using the wrong type of wire can lead to premature failure and create a safety hazard. In summary, the wire gauge and type specified in the wiring diagram are critical components of a safe and reliable spot hub electrical installation. Using the correct wire gauge and type ensures that the circuit can handle the expected current load without overheating or experiencing excessive voltage drop. The AHJ will typically inspect the wire gauge and type to ensure that they meet the requirements of the wiring diagram and the NEC. Always follow the wiring diagram and consult with a qualified electrician to ensure that the electrical installation is performed correctly and safely. Now, let's discuss ground fault circuit interrupters, or GFCIs, and their vital role in spot hub safety. GFCIs are designed to protect people from electrical shock hazards, especially in wet environments like those surrounding spot hubs. A GFCI works by monitoring the current flow in a circuit. If it detects a difference of as little as 5 mA between the outgoing and returning current, it will trip the circuit, cutting off the power supply almost instantly. This difference in current indicates that some of the current is leaking to ground, which could happen if someone were to come into contact with a live wire. The NEC requires GFCIs for all receptacles and electrical equipment located within a certain distance of a spot hub. This distance typically extends several feet from the inside walls of the spot hub. The wiring diagram will often indicate whether a GFCI is required for the spot hub circuit. If it is, the diagram will specify the location of the GFCI and how it should be wired into the circuit. GFCIs can be installed in several different locations. They can be built into the circuit breaker, installed in a receptacle, or installed as a separate device in the wiring. The AHJ will typically inspect the GFCI installation to ensure that it is properly wired and that it is functioning correctly. They may also test the GFCI to make sure that it trips when it detects a ground fault. It is important to test GFCIs regularly to ensure that they are working properly. Most GFCIs have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip and cut off the power supply. If the GFCI does not trip, it should be replaced immediately. GFCIs are not foolproof, but they provide an important layer of protection against electrical shock hazards. They can save lives by quickly cutting off the power supply in the event of a ground fault. In addition to GFCIs, proper grounding and bonding are also essential for spot hub safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding connects all metal parts of the spot hub together, which helps to equalize the voltage potential and prevent current from flowing through a person who touches two different metal parts. The wiring diagram will typically specify the grounding and bonding requirements for the spot hub. It is important to follow these requirements carefully to ensure that the spot hub is properly grounded and bonded. In summary, GFCIs are a critical safety component of spot hub electrical installations. They provide protection against electrical shock hazards by quickly cutting off the power supply in the event of a ground fault. The NEC requires GFCIs for all receptacles and electrical equipment located near a spot hub, and the wiring diagram will often specify the GFCI requirements for the spot hub circuit. Always test GFCIs regularly and follow the grounding and bonding requirements to ensure a safe electrical installation.